Day 1 of 90 focused on Rust setup and cargo basics. The goal today was getting the Rust toolchain and cargo workflow into a repeatable state from the first run. I did not want a crate tour. I wanted a model I could still explain after the demo code grew into a real application. The first concrete check was toolchain installation and versions. That sounds small, but it decides whether the code reads like a contract or like a lucky sequence of library calls. The second check was cargo commands that form the daily loop. That is usually where bugs start if the edge of the system is vague, because bad assumptions leak deeper into the app before anyone notices. The third check was crate layout that will survive later refactors. Once that was visible, keep the cargo layout and crate boundaries simple enough that responsibilities stay obvious. That is what made the lesson feel reusable instead of tied to one tutorial example. The implementation only started to feel solid once use cargo run, cargo check, cargo test, and cargo clippy as part of the normal feedback loop instead of as afterthoughts. In Rust, that usually means the types, ownership rules, and crate wiring all need to agree about who owns each decision. I kept returning to one more rule: treat the project shape as something future features must survive, not something to redo every week. That is the part that shortens debugging because the code tells you where to look instead of forcing you to reconstruct the intent from scratch. The predictable mistakes were treating the cargo layout as disposable and rebuilding the same skeleton every week and waiting to standardize build, lint, and test flow until the repo is already tangled. They look different on the surface, but both come from letting convenience win over clarity. So my recap for day 1 is simple: getting the Rust toolchain and cargo workflow into a repeatable state from the first run. Keep toolchain installation and versions, cargo commands that form the daily loop, and crate layout that will survive later refactors visible, and the code stays much easier to test, explain, and change. One reason I keep drilling these days is that production changes usually alter the surface area, not the core contract. If the contract is clear, the refactor stays local instead of infecting the whole project, and that is a much better place to be when release pressure shows up. That is especially true in Rust, where traits, async runtime choices, CERD models, and ownership boundaries can all make the code look more connected than it should be. Clear ownership prevents the drift and gives you a much smaller search space the first time something breaks. A lot of debugging time disappears when the request path, async path, or ownership path is obvious from the structure. The language and libraries help, but only if the design is honest and the boundary is visible in naming, types, and flow. My test is simple: could I explain this same design tomorrow with a different example and still keep the same reasoning? If yes, the lesson probably landed for real. If not, I probably memorized a recipe instead of understanding the trade-off. I also ask where the next teammate would hesitate. That question usually points at the first boundary that is still implied instead of stated, and cleaning that up early is almost always cheaper than doing it after 2 more features land on top of it. When the code is shaped well, the types, handlers, tasks, and logs tell the same story. When they do not, the mismatch shows up in review before it shows up in production, which is exactly where I want the correction to happen. That is why I keep practicing with one concrete path at a time. A small path is enough to reveal whether I understand the design or only recognize the tooling around it, and that is a much better signal than just getting the sample app to run once. The pattern I am looking for is repeatability. If I can take the same boundary, reuse it in a slightly different context, and still trust the behavior, then I know the lesson moved from recognition into working engineering judgment.